Hi, and welcome to 7th grade math class. We are working on exercise 3.5. This is in your book on page 110, and we're going to talk about solving two-step equations today. So we're going to go through some slides. I'm going to talk you through it. You're going to look at this window down here, and you're going to see me solve a lot of these as we go along. Now, some of them I'm going to ask you to do on your own. So get out a piece of paper and pencil, hopefully in your spiral notebook that you're using for 7th grade math, or in a 3-ring binder that you're using. You're going to need to take notes and solve problems as we go. So you've been solving one-step equations, and solving two-step equations is just building on top of that. You're doing the same thing, but you're not just doing one operation and getting your answer. You may have to do one and then another one in order to finally get x is equal to some number. And that's what we're after. So let's start, and we'll be really clear on what our learning goal is. Our learning goal is to use inverse operations to solve two-step equations. So in this problem, we see that we have 3 times x, and we have we're subtracting 10. So the inverse of multiplication would be division, and the inverse of subtraction would be addition. So the first thing we're going to do is add 10 to both sides, because whatever we do to one side, we have to do to the other. We're left with 3x equals 24, because this cancels out and 14 plus 10 is 24. Now we're going to do the inverse operation. Here we have multiplication, so we're going to divide both sides by 3 to solve for x. And when we do that, we find that x is equal to 8. Just like that. We've solved it in 2 steps using inverse operations. So now I want you to imagine that you and your friends are going bowling. It costs $5.50 just to rent the shoes, no matter how many games you play. And it costs $2.50 per game. So you spent $13, and you're going to write an equation to figure out how many games you bowled. So we know that the constant here would be $5.50, and you paid $2.50 for X number of games of bowling. So that's our equation. Now we're going to solve this in 2 steps. The first thing we're going to do is the inverse operation. So we're going to subtract $5.50 from both sides. And when we do that, we're going to have to borrow from this 13, remember, subtract it out, and we end up with 2.5x equals 750. So this is times the inverse operation would be division, right? So we're going to divide both sides by 2.5. And when we do that, we get x is equal to 3. So just to remind you, when we're solving two-step equations, our goal is to isolate the variable using inverse operations. Step 1 is to identify the constant in the equation. You're going to add or subtract it from both sides of the equation. So just like we did here in our first equation, we identified that this is our constant. This is our variable term, and we're going to do the inverse operation. So here it was subtraction. Instead, we're going to add to both sides, because whatever you do to one side of the equal sign, you have to do to the other to make it a balanced equation. Remember, you're going to think about what would I have to do to make this constant 0, okay? So if you added negative 10 plus 10, that would be 0, and you see it vanish from our equation. And over here, we add 10 to both sides, and we see that now we have a balanced equation. Step 2 is to divide both sides of the equation by the coefficient to isolate the variable. So here, 3 is our coefficient, and we've divided by 3 on both sides. And isolate the variable means that you have written it in a form where it's just x equals some number, okay? And you're going to hear me tell you this 100 times if you hear it once. Whatever you do to one side of the equation, you have to do to the other side. Those are the properties of equality. Whatever you do to one side, you have to do to the other side. So let's solve this one together. First, we're going to locate our constant, which is negative 10. So we add 10 to both sides. Wait, we already solved this one, didn't we? Let's do the next one. Okay, first thing we're going to do is find our constant. Here's our constant, 24. Then we're going to do the inverse operation. So instead of adding 24, we're going to subtract 24 from both sides. So this equals 0 here, so we can just rewrite our 5x here. That vanishes because 24 minus 24 is 0. Now we're adding up two negative numbers. So we know that our answer is going to be negative, and we can just add them up. 36 plus 24 would be 60, and it's negative 60 because they were both negative. Now we are going to identify the coefficient in front of our variable and divide both sides by that. So we divide both sides by 5, and we find that x equals negative 12. Remember, a negative divided by a positive is still a negative, and we have isolated x and solved for x right there. Here's the next one we're going to do together, and it's flip-flopped from how we saw the last several. But first thing we're going to do is find the constant, and we're going to do the inverse operation. So we're going to subtract from both sides. Whatever you do to one side, you have to do to the other. Then we rewrite it. 15 equals 3x. Now we're going to find the coefficient. It's 3 times x. So instead of multiplying, we're going to divide by 3. Whatever you do to one side, you have to do to the other. The 3 divided by 3 cancels out to just 1. So we're left with just x on this side. 15 divided by 3 is 5. So 5 equals x is the same as x equals 5. This is a little bit prettier when we're solving for x to put the variable first, but this means the same thing. So let's solve the next one in our 2 steps. Where's the constant? Boom, there it is. So we're adding 17. Instead, we're going to subtract 17. That's our inverse operation. And whatever you do to one side, you have to do to the other. So 17 minus 17 gives us 0. We're just down to 9x on this side. 71 minus 17, we'll have to borrow. 11 minus 7 is 4. 6 minus 1 is 5. So 9x equals 54. Now we have 9 times x, so we're going to divide both sides by 9. That's the inverse operation. This cancels out to just 1, and we are left with x equals 54 divided by 9 is 6, so x equals 6. Now we're going to do a couple examples with the distributive property. So remember, you have to distribute whatever's outside the parentheses to each term on the inside. So 3 times x is 3x. 3 times negative 4 would be a negative 12. Now we're ready to do our 2 steps. So we find our constant, use the inverse operation on both sides. 3x equals 21. We divide both sides by 3. 3 divided by 3 just leaves us 1. 1 times x is just x. And 21 divided by 3 is 7. So we're going to do another one with the distributive property. I want you guys to be super solid with this. 2 times x gives you 2x. 2 times 7 gives you 14. This stays the same. This is our constant, so we're going to use the inverse operation. Subtract 14 from both sides. Then we're left with 2x equals negative 26. We divide both sides by 2. And x equals negative 13. We have solved for x. Good. So we're doing the same thing now just with fractions. This is our constant. So we're going to do inverse operations. We're going to subtract 9/4 from both sides. Okay? We are left with 1/2 b equals 7/4 minus 9/4. You can stack it up next to each other if you want to. We know that when we're adding or subtracting decimals, the denominator stays the same. 7 minus 9 is negative 2. So here we have negative 2/4. Okay? Now, another way to rewrite this, negative 2/4 would be a negative 1/2, right? So now we can actually just rewrite the equation. So we have 1/2 b equals negative 1/2. We're going to multiply by the reciprocal. Yay! You guys remember doing that. So we're going to multiply by 2 over 1 on both sides. This cancels out to just 1, so we're left with b equals a negative, this cancels out too, just a negative 1. So b equals negative 1. We're going to do one more so you don't have to be afraid of fractions. Here's our constant, so we're going to subtract 5/6 from both sides. Subtract 5/6. So we have 3j equals all this. Now, in order for us to subtract fractions, they have to have the same denominator. So let's rewrite this as negative 4 6, right? We're going to multiply the top by 2 and the bottom by 2. Negative 4 6 minus 5 6. So our denominator will stay the same, and negative 4 minus 5 is going to give us a negative 9. Okay, we could actually simplify this, couldn't we? So we could go 3j equals, divide top and bottom both by 3, right? We're going to just reduce that fraction to simplest form, negative 3 halves. Now we're going to divide both sides by 3. But one thing that you can do is multiply by the reciprocal, and that's going to help us when we're doing fractions. So we're going to multiply by 1/3, and that's the same as 1. And if we do it to that side, we have to do it to this side. Multiply by 1/3. Our 3's will reduce down to just 1, and then we are left with j equals negative 1 times 1 is negative 1. 2 times 1 is 2. So j equals negative 1/2. So as we conclude our lesson, just remember that you can solve two-step equations. First, you're going to use inverse operations to move your constant to the other side, and then you're going to use inverse operations to isolate your variable. So good luck with this. Please do your homework and let me know what questions you have. Bye.